Hi guys. So first of all, welcome. I'm really happy that you are here with us. Our talk for the day is actually a funny, scary talk. It's basically 5 easy ways to spoof your contributor package reputation. So this is quite a practical talk. I hope you will use the knowledge that I will share here for good stuff, not for bad stuff. So let us introduce ourselves. My name is Tzachi, Zach. I work at Checkmarks. We founded the company with my partner Joseph a couple of years ago, focused around detecting attackers in code packages. And I'm more than thrilled to introduce Guy.
Hi, I'm Guy. I'm a software engineer at Tzachi's team, at the supply chain security team.
Take it for it. So as I like to call it, Pinky in the brain. He's the brain, I'm Pinky. So basically, we're going to talk about something that everybody uses on a daily basis. Basically, we're going to talk about how to abuse the open source ecosystem. And the reason why it's an interesting topic is basically everybody uses open source. Most of the code in our apps actually comes from open source. This is the only way to develop a modern application. And this is the status quo. Basically what it means that developer wants to deliver fast. They want to use open source. They are, as my partner Joseph called them, a lazy programmer is a good programmer. You don't want to reinvent the code, you just want to reuse the other component. And that's great, we all understand that. But for me as a security researcher, what was puzzling was the question, how do people actually trust this code? Who's validating the code? Why do we automatically take code from strangers? So researching that, we quickly realized that developers tell to themselves that I don't have time to do a code review. I have a lot of other things to do. But if it's open, somebody else, I don't know who somebody is, but somebody else will review that code for me. And if there is a problem, someone will notice. Someone will fix that for me. And one of the main things that we like to tell to ourselves, I'm only going to use popular packages because if it's popular, it must be safe. If there's a lot of stars, it must be okay. And this will be a major part of our talk going today, trying to realize that. And of course, it gives us a trustworthy feeling. I mean, everybody's doing that. Everybody's using open source. I'm just like the other guy. So those assumptions that we tell ourselves as developer have not gone unnoticed by attackers. Actually, attackers have taken notice. And if some of you are actually following us on Medium or other social, we've seen a huge spike in number of open source package compromises in the last year. It seems like every other year we are actually finding a new attack and a more sophisticated attack. And some of those attacks are actually based on popular packages. So what we've come to learn this year and to share with you is basically popular doesn't mean safe anymore. And we're going to show you how attackers are actually abusing that to get ahead of the competition. So 5 different methods, like a magazine. The first one, starjacking. So what is starjacking? Starjacking is basically an attack that looks like this. So we have 2 packages here. So this is kind of an attack we called typo squatting. I'm going to show you what starjacking is on top of typo squatting. What does it mean? Typo squatting means those packages seems pretty much the same. They have the same, description, but what the attacker is doing is deliberately misspelling one of the package name. Understanding if this is a popular package, some developer by mistake could misspell the package name and download the wrong package. Okay, but if a developer will download the wrong package, wouldn't he notice? Actually not. Because in this example, both Pumpy and Pumpy.io have the same code base. So the developer wouldn't notice he actually took the wrong package. But and there's always a but. One of those packages, and now I can share with you the pump.io is the malicious one, has another dependency. And in that dependency, there is something unique in evil. So this is a security for researchers. Can you understand what's written in the first URL? Why is there the -1 there? So we can easily detect, actually it's a reverse URL, actually running on an open platform. So basically what the attacker is doing with this type of squatting attack is stealing my developer credentials and sending him to his control infrastructure. But wait. Okay, I understand that pump.io is the malicious package, and developers should be aware, but we're always telling for developers, guys, before you download something, check the reputation. So basically, I'm going to simulate an open source attack and show you from the attacker point of view how it looks like. So when we want to create a new package, basically all we need is an identity, nothing more than an email. Any Gmail could suffice. That's it. There is no background testing. The second thing that we need is metadata. So what do I mean by metadata? In this example, I'm going to give supply chain demo, but I could have given it like pump.io 2, pump.io next generation, something similar to my intended target. Pick a version. Never pick version 1. Developer doesn't like to download anything with version 1. And now's the magic part. PyPy doesn't know me as a developer. It doesn't know where I come from. So basically, in this stage, it's asking me, okay, cool that you want to open source this code package, but where did this code came from? So I'm not a company. I don't have any other projects. So basically, what I'm doing as an attacker, going to the trending GitHub projects, choosing one of them, in this example, the Economist ebooks, which has no connection to what I'm doing. Wait for it. What just happened? Basically, there is no vetting. You can declare on any package, it's Kubernetes code, it's React code, and get all those stars. It's that easy. 5 easy ways, right? This is number 1. So basically, after that, what me and my team will do, we'll write some kind of a malicious payload. In this example, this is what we call a dynamic downloader, meaning the code will run, we'll go to pastebin, parse some code from there, and then actually go and open it in a remote shell with interact SSH. That's easy. Basically, that's the code, supply chain demo, the version, the name, the Git URL, publish. That's it. That is everything that we need, wait for a minute, to actually steal the reputation of a package. And this is, by the way, not limited only to PyPy, what we call starjacking. We have the same variations on NPM, Maven, and other languages. So for the second method, I'll let the guy take over.
So the second method we're going to talk about today is repo jacking. Repo jacking is an attack that happens when a user changes his GitHub username. So for example, for my New Year's resolution, I want to become better, I want to become more cooler, and I'm going to change my username to Tzachi.
No, definitely not.
So when I change my username, if my old username was Guy, and now it's Tzachi, each time someone will go to github.com/guy, will be automatically redirected to github.com/Tzachi. GitHub does that so it prevents everything from breaking apart. Every reference that belongs to Guy will now belong to Tzachi. But there's always a but, right? The old username is still free. Everybody can use it. So what will happen if someone will take my username, my old username? When that happens, everything stops. The redirect stops, and basically each time someone will look for me, for my old username, it will get another person. Not me, not my new name, not Tzachi, but it will go to a different guy. This method was used by attackers to hijack accounts, and in the current year we disclosed it to GitHub, we talked about it with them, and this breach, specific breach, was closed. And what they did was that they prevented users from reusing popular repo names on renamed users. So if someone will now go to Guy and try to create a repo that I had that was popular, he won't be able to do that. The naive person might say, okay, this is done, great, thank you. What are you talking about, right? But as you know, developers never stop and they keep on evolving. So they found another way to manipulate the system. This manipulation happens in a kind of more complicated way, but it's pretty easy. So if I'm an attacker, I'm going to open a new GitHub account. I'm going to call myself attacker123 because it's not that suspicious. And I'm going to open a new repo that I targeted. So if I want to target Tzachi's repo, I'm going to open a new repo under my name and name it the same as Tzachi's. Then I'm going to delete this repository. So it will be associated with my account, but it won't be actually alive. The next thing I'm going to do is I'm going to rename my account to the old username that I'm attacking. So if Tzachi was Guy, I'm going to rename my account to Guy. Then I need to wait for an hour. And then I'm going to restore the target repository. So basically, if I had a repository that I deleted, I'm going to make it come back to life, and I will bypass GitHub's procedure. You might ask yourself, what is the impact, right? Because, okay, you can manipulate some GitHub repositories, but actually, if you don't know PHP, Go, and Swift manage the packages on GitHub. So that means there are over 10,000 vulnerable repos, and immediately right now, there are thousands of packages that are sustainable to this attack. In order to help developers confront this, we released an open source tool called Chainjacking. You can go to Checkmark's GitHub page, and you can see it there if you'd like to use it. And in this occasion, we'd like to thank GitHub for working together, for working with us on disclosing and solving this issue.
Thank you, Guy. And trust me, you should trust Guy. Just check his GitHub account, and you see how active of account he is. So basically, I've started with a package, and then we talked about a repo. But who creates all these codes? Who is the person that we trust? We don't trust the code, we trust the person, right? How do we trust these people? So basically, we're always saying if it's good for them, it's good for me. If this person is active and popular, it must be okay. And basically, I'm going to show you another method to fake, in this time, a contributor or a user on GitHub, using what we call fake commits. Basically, if I would go to this person who is trying to preserve me, take my code, looking, to start from the beginning, let's start with start checking. So if I were to go to this person and look at the code there, I wouldn't take his code. I don't know Zach, he's not active. Why should I trust him? Now, too dangerous. On the other hand, give me a couple of minutes. Now I want to take Zach code. He works at Facebook. He's been active every day for the last couple of years. It's green, it must be okay, right? Let me show you. So basically, when in the protocol of Git, there are two fields that you can write whatever you want to. First one is time. You can always declare what time the commit was made of. Interesting. Second one is who made it. And there is no validation by default on any of those fields. Do you see where I'm going at? Let me show you. Basically, let's go again into our demo. So we have, let's see. We have an account on GitHub, Zach's account. So basically, you can see that Zach is inactive. We don't see a lot of activity. The black one is a bit problematic to see in a minute. Now I'm going to go back into what we call our Metasploit for open source attack. And we're going to create Zach as a senior developer. In one swift moment, I'm going to take Zach from earning little money to a lot of money. And that's easy. Basically, what I'm doing is I'm committing a lot of commit, and I'm just manipulating the date. Nobody's checking. So in a minute, I can actually, seems that Zach account, and the action is finished, is basically very popular. Now I will take his code and pay him twice the salary I wanted to. So it's basically that easy just to fake the activity, and that seems legit. And by the way, there is no way to stop this because it's part of the standard of GitHub. And we have been trained as consumer, if something is green, it must be trustworthy. So this is Zach. He has a product. Maybe I will actually use his product. Next. But one final problem. Before I'm going to use Zach D project, there is a problem. Not a lot of people have contributed the code to this project. I don't want to use an open source project which is maintained by maybe very hardworking, but with just one contributor. How can I solve it? I'll let Guy answer that.
So I'm going to up the ante a bit, and I'm going to show you a cool method to fake a contributor on your repo. So if Tzachi showed you how to fake commits from yourself, I'm going to show you how you can say, hey, I'm not me, and I'm committing to this project. So let's make it more interesting. As you can see, this is our demo system. We are going to just click on Add Contributors, and in 3 seconds, you're going to see 2 more contributors added to our repository. And voila. You might be a bit confused, right? Because how can we do it? How can we commit in the name of another person? Don't worry, I'm going to explain everything. So if you don't know this person, this is Joe Spolsky. He's a cool man. He's the man behind Stack Overflow and Trello. And I thought to myself, if someone is going to contribute to my repository and make it popular and safe, it'd probably be Joe Spolsky, right? So in order to fake or commit from him, I'm going to go to a previous commit that he made on Blinky, one of his projects, and I'm going to add to the end of the URL .patch. This is going to take me to a page with a lot of metadata, but inside of that, there's his email. And basically, that's all I need. I'm going to tell GitHub, hey Git, config me as Jay Spolsky, which is his username, config my email as his email, and commit. And that's it. He's now a contributor to my open source project. Now, some of you might say, okay, that's cool, but we can verify a commit, right? There are verified commits. But there's a problem here, because when you go through a project with 700 commits, you won't see on each commit outside of the commit itself whether it's verified or not. So in order to see a verified commit, you need to go into the commit, look at the code, and then at the top, you'll have a button saying, this is verified. And I don't believe that any one of you will do it in a project at a large scale. Now we're going to go to the last and the most cool.
Yeah.
And
so before that, just one thing. There is a thing called verified commits. And I do encourage all developers, and even in your accounts, to activate verified commits. And then you can get notification if somebody will try to use your name, especially if you turn it under paranoid mode. The problem is that the way that we see it on the UI, on the GitHub UI, doesn't tell us if it's verified or not. And that's a big part of the problem, because if you're showing me data, I will automatically presume this data is okay, legit, is green. What's the problem with verified? So we like verify as long as you verify the right way. And now Guy will show you how to verify in the wrong way, in our 5th method.
So this is a bit complicated, so I need you to brace yourselves, because there's a lot of code and manipulations and attacks. So let's talk about verified. Now I'm going to show you how you can verify yourself as a worker for a workplace that never heard of you. So this is my GitHub profile. You can see I'm very popular. I'm trending. I have 1 follower. And I decided to change my workplace. So right now, if you'll hover over checkmarks at my profile, if I'll click on it, it will take me to checkmarks GitHub page. I decided to change, and I'm going to change checkmarks to CyberArk because I want to work there. So I will write CyberArk and save, and automatically they assume that I work for CyberArk. If you'll see I hovered, it gives you info about CyberArk. But
wait for it.
This is not verified yet, right? But Facebook, for example, they verify the workers. So they want to verify who works for them on GitHub. And right now, if you'll take a look, when I hover over Facebook, it shows me as a verified worker. So basically, they do not verify anything. They just verify automatically.
We verify there is a company called Facebook. But we expect developer to understand that the verify there doesn't mean that you work there. So when I'm talking about showing us the right information, that's exactly what we're talking about. Okay. So basically, we wanted to show you a couple of the stuff that we've been seeing. And this is just a couple of those, because basically, as I started my talk, we are seeing more and more attacks on open source packages, and we are seeing those techniques at work today. So although this is a conference for researchers, attackers are abusing these methods today, and they're actually even a bit more straight about it. I want to give some credit to Guy and to Tal and the rest of the team. A couple of weeks ago, we found a malicious package that basically was part of a TikTok malware campaign. But what I'm saying is we are seeing attackers starting to build their online persona, starting to realize that if they'll invest time in building good reputation, people will be fooled. And what we have shown you, it's much easier than what attackers are thinking. And we have done that in a couple of ways. The first way was starjacking, basically how easy it is to give an open source package on PyPy, for example, the legitimacy, the number of stars of a well-known project. Really no code. Just say you're part of React, just say you're part of Kubernetes, that's it. There is no vetting. When we approach PyPy with those, and we really like working with the PyPy security team, they basically says, guys, this isn't a vulnerability. This is working as intended. We need to fix that, but this is not a vulnerability. And it's open for a couple of years. So good luck with that. Second thing that we've shown you is around repo jacking, the ability to steal access to popular repos, abusing a mechanism that is the rename. So is that as a real world impact? Basically, even that GitHub has some mechanism in place called retired namespace, we actually saw 3 vulnerabilities this year bypassing this. We actually saw one attacker abusing that live before the vulnerability was fixed, and we do believe that there are other hint, vulnerabilities in this mechanism. So as a security researcher, I would recommend looking at that. The other one that we actually saw is fake commits. And to be honest, those aren't necessarily fake. What is fake is the timestamp and the contributor. Will we see this vulnerability fixed? And the answer is no. Why? This isn't a vulnerability. This is by design. By design, you can declare the time of the commit, and you can declare who set the commit. And it's really easy for attackers to abuse that. And fake contributors, the same mechanism as we just said, is basically I can have Linus Torvalds committing code to my repo, and people looking at the list of contributors will automatically assume everything is okay. Everything is okay because it's been presented in the front page, so I should take this bucket. And the last one, basically, which is, to be honest, just bad UI, is the fake organization. Now, you don't need to use one method. You can use all of the methods. Think about using building a fake developer, giving him a fake package with a lot of stars, and then he is very active. He has multiple projects. He works at Google. Everybody's contributing to his code. So bundling everything together can really make a damage. So those are like 5 easy ways to show you what attackers can do and how easy it is to steal and buy someone's reputation. Be happy to take a couple of questions. We don't have a lot of time, but go ahead, guys. Any questions? What do I mean to mitigate? So there is no one advice. First of all, awareness. Be aware that what you've seen isn't necessarily true. In the case of attacks like starjacking, click on the link, go to see where the GitHub is. We actually released a couple of open source tools that we actually talked about before to identify those fake, non-verified commits. And I hope you can get a true map of what is real, verified, and what is supposed to be real. And then you have to make your own decision. So we are releasing a lot of tools and out of those research, and we are seeing attacker abusing that today. Any other questions? Cool. So I hope you find, we actually have like one more extra bonus method to show you, which is the deadliest of them all. But before that, I hope that you found this lecture entertaining. You know what, we'll do the extra bonus first, wait. So the bonus method is combining all of those methods together. Actually, the most sincere, the most undetectable attack that there is get your own fake commit, get everything. You want to be a part of a project? Just ask. Because the open source ecosystem is built on security. And in so many cases, the only thing we needed to do is just ask for access. And then, sure, you're a maintainer. We need to understand people are doing that in the spare time. They would love the help. If it seems that you are credible and have good reputation, they will just hand over the keys for the system. So we do, cool, starjacking, repo jacking, everything, but sometimes all you need to do is just ask. And this is a couple of examples that Joseph, my partner, had on his project, and people just came to him and asked, can we just get access? And of course, if the person seems legit, active, credible, why not, right? So thank you very much, guys. One last question from me to you, and I hope you found this lecture entertaining, is basically, this is what...
Are you not entertained? Are you not entertained?